we're going to take a look at how to condense log expressions into one log. So there are three main rules that we have. If you have log base b of x, y, it can be written as log base b of x plus log base b of y. So these are similar to our exponent rules, that if you're multiplying, you're going to add in between. I also have log base b of x divided by y, and that can be written as log base b of x minus log base b of y. So here I have a subtract from dividing, which is similar to your exponent rules, where if I had like x to the fourth over x squared, I would subtract the 4 and the 2. And then the multiplying one, if I had x squared times x to the fourth, I would end up adding the two exponents instead. So our last rule has to do with having a power. So if I have log base b of x to the r, what I can do is multiply the r out in front. So I get r log base b of x. So this would be similar if I had x squared to the fourth, and we end up multiplying the 2 and the 4. So this is kind of how I remember the rules that go with expanding and condensing logs. It goes with your exponent rules. So if you're multiplying the ofs, you split to 2 logs and put a plus. If you're dividing the ofs, I split to 2 logs and put a minus. If you have a power with the of, it gets multiplied out in front. So those are our three rules that we're going to be using as we're condensing. Now, condensing means that it wants it written as one log rather than several logs. Okay. So if I give you one that looks like 18 log base 8 of a minus 6 log base 8 of b. So what I'm going to do here is any number that's being multiplied out in front, I'm going to move it to a power for the of spot. So the 18 moves here, and the 6 moves here. So then I'll end up getting log base 8 of a to the 18th minus log base 8 of b to the 6th. Now, remember that our subtracting, I can write it as one log, but put a divide in between the of spots. So this is your of here, and this is your of here. So I'm going to have log base 8 of a to the 18th over b to the 6th. Okay? I know I'm done condensing when I don't have anything being multiplied out in front of the log, and I don't have more than one log. So see how log is only written once? So now I know that I'm done. So we went from 2 logs into 1 log. So we're condensing into 1 log. So let's take another look at a problem. Okay, so if I have something like 2 log base 4 of x plus 6 log base 4 of y. So because the 2 and the 6 are being multiplied in front of the logs, I'm going to move both of those to a power with the ofs. So this is going to be to the power, and this is going to be to the power. So I have log base 4 of x squared plus log base 4 of y to the 6th. So I am going to multiply, because I'm adding, I'm going to write this as one log, multiply in between the two ofs that we have. So I'm going to have log base 4 of x squared y to the 6th. Okay? I have only one log, and there's nothing out in front of the log, so I know I'm done with condensing the log. Now, we also have a situation where you could have a fraction out in front of the log, and your fraction can be written one of 2 different ways. So if I have log base 8 of w plus log base 8 of u over 3, plus log base 8 of v over 3. I could have it written like this, or I could have it as log base 8 of w plus 1/3 log base 8 of u plus 1/3 log base 8 of v. So both of these are the exact same thing. There's just two different ways to look at it. Notice here that there's an unsaid 1, and here's an unsaid 1. So this is really the 1/3 that we see here, and this is also the 1/3 that we really see here. So since I have these two, either one of these, notice that I've got the 1/3 out in front, or here I would think of the 1/3, and it's going to go to the power of, for the of spots. So this is going to turn into log base log base 8 of w plus log base 8 of u to the 1/3 plus log base 8 of v to the 1/3. Okay. So notice between all of our logs that they are being added. So all three of these of spots are going to be multiplied when I combine it down to one log. So I'm going to have log base 8 of w, u to the 1/3, v to the 1/3. But remember, your fractional powers can represent a root. So I'm going to rewrite these as a root. So it's going to be log base 8 of w. Then I'm going to do, since this is a 3 on the bottom, it's going to be a cube root of u to the first power times v to the first power. Okay? So this number went underneath the root, and this is this kind of root. So because both of these have the same denominator, I can write it as one root. Now, it looks a little bit weird to have the first powers written, so I'm just going to undo that. And then I have log base 8 of w cube root of uv. And then I'm all done because I don't have anything being multiplied out in front of the log, and I don't have more than one log, so I know that it's condensed all the way. Now, we can make it so that it gets a little bit more complicated, where I have several adding and subtractings all in one. So if I give you something like natural log, remember natural log just has a base of e, so all of these properties also work with natural log. So if I give you natural log of 2 plus natural log of x, let's put a 3 out in front, plus 5 natural log y minus 6 natural log z minus a half natural log p. Ooh, so close to being out of space. So here I'm going to take all of the numbers that are in front of the natural log, and I'm going to make them into powers for the of spot. Oops, there, 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 and there. Okay. So then this is going to turn into, notice on this one that we've mixed numbers and letters. So we have a number here, and these are all variables, which is fine. So I have natural log 2 plus natural log x cubed plus natural log y to the 5th minus natural log z to the 6th minus natural log p to the 1/2. Okay. So what I'm going to do here is I'm going to take a look at all three of these together. So all three of these are being added, which means I can condense it into one natural log and multiply in with the ofs. So I'm going to have the natural log of 2x cubed y to the 5th. But I still have this minus natural log z to the 6th minus natural log p to the 1/2. Okay, so I'm first going to take a look at this, and then I'm going to take that into consideration. Okay, so because these two things are being subtracted, I'm going to divide. So I'm going to do natural log 2x cubed y to the 5th over z to the 6th, but we still have minus natural log p to the 1/2. Okay, so now these two things are being divided, or sorry, they're being subtracted, so I'm going to divide them. So I'm going to have natural log of 2x cubed y to the 5th over z to the 6th all over p to the 1/2. So really, I'm going to make this natural log bigger. Natural log. Okay. This is nasty, right? So we want to simplify this. This is called a complex fraction, right? Because we have a fraction within a fraction. Okay. So remember, the p to the 1/2 is really over 1. So I'm going to flip and multiply, because how you divide by fractions is to multiply by the reciprocal. Remember, the reciprocal is just flipping it. Okay, so I'm going to multiply this part here. So when I multiply this part here, this portion right here turns into 2x cubed y to the 5th times by 1, which is just 2x cubed y to the 5th, over, and then the z to the 6th and p to the 1/2 are going to be multiplied. So I just end up with z to the 6th, p to the 1/2. So then my answer is going to be natural log 2x cubed y to the 5th over z to the 6th, p to the 1/2, like that. Now, we're going to have to change that to radical, but before we talk about that, notice the 2, the x, and the y, if we look back up here, this has a positive in front of it, the x has a positive in front of it, and the y has a positive in front of it. If we look at what's in the denominator, I have the z has a negative in front of it, and the p has a negative in front of it. So what you can do is you can actually shortcut this whole process, and if there's negatives, that means they go in the bottom, and if there's positives in front of the log or the natural log, that means they go in the top or the numerator. So I can actually end up shortcutting this whole process, so I can actually go from the very beginning to the very end. I personally don't require work shown for expanding and condensing, but depending on what circumstance you're in, you may need to have work that's similar to this. But notice if you encounter any time where you have two negatives, that they'll both end up in the denominator, or any combination of multiple negatives, that they'll end up in the denominator in the of spot for the log or the natural log. Okay? And then we want to change the p to the 1/2 to a root, so I'm going to have natural log 2x cubed y to the 5th over z to the 6th, and it's going to be a square root because of the 2, and then I'm going to have a p to the 1st power, so it's going to be over z to the 6th square root p. Now, previously, we have told you that we don't like roots in the denominator, which is true. We don't normally like roots in the denominator. In this case, where we're expanding and condensing, in the case of expanding and condensing, it's okay to have a root in the denominator. Typically, we don't have to rationalize that because it ends up looking way more nasty than we need it to be. So this is an exception to our rule where you're not supposed to have a root in the denominator. So this is an acceptable way to write that. And that is how you go from an expanded log or natural log to a condensed natural log when it's just in one, you just have one log or natural log.